Wait.
Yeah, we can go. So it's only us here. It's gonna be a small. Hopefully, more people will join.
Sure.
So we're gonna talk about machine learning, Cyberarmor, and then AI enhanced strategies for threat detection. It sounds like the future, man.
It's already present, it's not present future.
True, that's true. Okay.
So you could stand bit back so that the video
Okay,
can
you
see you.
Yeah.
It's
Well,
recording.
You can start wherever you're ready.
Oh, it's recording, right, sir? Because it's there.
It's recording this one.
Yeah.
Right?
Click on more over there.
Mhm.
Yeah. Recording.
It's recording already.
Yeah, it's
Okay.
recording.
Okay.
Cool. Sir. Audio is also on.
And we are sharing the right screen. Right?
Yeah.
Actual meeting, you can check. Okay.
So,
all right. So good afternoon, everyone. Thanks for joining this session on ML Cyberarmor. Today we'll be discussing about AI enhanced strategies for threat detection. Today we'll be discussing about AI enhanced strategies for threat detection. Today, if you look at the cybersecurity landscape, there's a growing threats, be it advanced persistent threats, ransomware, phishing attacks, and cyber threats. So, advanced persistent threats get is a way of stealing the data by silently getting into the systems and being unnoticed there. And then also ransomware attacks. We've seen phishing attacks is one of the first attack vector that's been used by in the cybersecurity. And we also see insider threats from the ones inside and as well as outside. Basically, if you be contractor, you're an employee, they're the source, being involuntary and voluntary. They expose the data. This is one of the major threats we've been seeing as well. The scale and complexity of this is happening is also raising. That's when we feel that the legacy ways the are challenged, like the limitations, basically the signature and rule-based detections that we have today. So if you look at the cybersecurity trends over the past 5 years, we can see that there are different kind of colors here. So on the left side is the impact score that is given by various security agencies like National Institute of Standards and Information. So if you look at the ransomware, basically, to just give somewhat idea about what ransomware is, people like the security attackers get hold of your data and then demand back some payments. There's not just for the one who's been attacked, the organization that has been attacked. It's not just the amount of money, but it's also the business continuity that is lost, and then the recovery time is also interrelated to the impact factor calculation. Next is the phishing attack. We've seen usually the ones inside the organizations have become are the ones who get into easily phishing attacks, and recently there have been growing phishing attacks as well, where QR codes have been circulated in the emails, and then they go unnoticed, and then usually people tend to scan them and click them. There are also supply chain attacks going on here. Like you would have heard about the SolarWinds cybersecurity attack, wherein their Orion updates network, which actually monitors the network, is compromised, and updates were pushed where all of its customers were impacted. This is a supply chain attack wherein an organization which is depending on some other third-party solutions are also impacted. APTs. As we discussed about getting access to these organizations, like Toyota also reported this back in 2020. Their information was stolen, and cloud and IoT, as with the emergence of IoT era, there've been a lot of devices which enterprises depend on, and as these devices get compromised, it's enterprises giving away their business, and they're also getting impacted. Now, if you look at the traditional detection mechanisms that we have today, they're basically signature-based or rule-based. What is signature-based? Basically, you have already existing digital footprints which are used to identify the threats. Let's, for example, take a login attempt, right? Okay, the user is trying to log in and a specific IP address. There must be static rules that says, okay, given an IP range, these are valid allowed roles. Now, if the organization starts to also allow from different IP ranges, then they have to update this signature page and the rule page as well. So what are the downfalls of this traditional ones? Basically, if any net new era comes in, then they have to be manually updated, and then any net new ones will go undetected. Like any threat also will go undetected. With the AI enhanced detection, it's adaptive, where it can learn from the new data patterns, and the learning is actually slightly subjective. Basically, I can say it depends on whether how frequent you want to learn. We'll come to that, and then proactive. Like basically, they can detect their issues even before they happen. And now coming to the ML model key life cycle. So like any machine learning models, it involves the data collection, then the pre-processing. Data collection, basically, the data is collected from network logs, endpoints, and user activity. And then the model is basically trained. So building a model so that it can recognize the patterns, it is trained on how to identify the threats, and sometimes also respond to threats. And then testing and validation. So basically, once in the cybersecurity space and in any other general ML model training, right, we ensure that the model is already tested well. So ensuring the accuracy to rigorous testing, wherein it is provided with the known threats and checks if it identifies as well, not just the known ones, but also the novel issues that are coming that emerge. Like ML models should be able to identify even the issues that are not known to it earlier. Next is monitoring and maintenance. Like we continuously monitor for the model performance. Basically, deploying a model is not the work is not done yet. We need to monitor it to identify the performance of it. If it needs some updations, and it has to be frequently updated with the latest data that happens. Retraining and updating. So regularly updating the model is key, because if not, it will lead to model drifts. We'll talk about it, why it's important. So we'll talk about the key ML techniques in threat detections. So what are the ways in which organizations can employ machine model learnings? So if you look at the supervised learning in general is dependent on the label data. Basically, you identify the threats already and label them across different various types of threats, and so that your model will be able to identify and then and then say that there is a threat given a given threat. So this if you look at it, it's actually relied on the amount of data. The more the data it has, and then the more better the supervised learning can be, and the model can be deployed. Whereas unsupervised learning, it is used to identify the anomalies. Like when I say identifying the anomalies, any novel threat, basically, like let's take for example user logins, like we were talking about, is if any user trying to log in at an order and then from a different area and trying to transfer a lot of data can be an anomaly. But how would an ML model detect this? So ML model is trained with a given with the data. It is not labeled. It's like raw data. It can use network logs. It can use the security reports from the organization, and then come up with some kind of clusters of data pileups. And these anything that deviates from this, any transaction that deviates from this is considered as an anomaly. So semi-supervised learning is another kind of learning where it combines both the labeled and unlabeled. Supervised learning uses accuracy, whereas unsupervised learning uses the adaptability. So companies, enterprise also use the semi-supervised learnings. Next is the reinforcement learning. So reinforcement learning basically allows you to continuously adapt to the emerging ones, and it can also give automated responses to the security threats. Transfer learning we've seen is also being used by enterprises. Basically, transfer learning is like basically transferring the domain knowledge of learnings from one model into another space. For example, a model that is trained the financial data can be used into other domains like financial, like retail, or can be used in the healthcare sector, because financial could have a lot of such attempts, and it has learned and is more mature. So these learnings can be applied into other domains. Next is the natural language processing. Basically, like natural language processing can be used to identify these and proactively detect the threats. It can be used to identify the security reports like I was talking about by itself, network logs, and identify, and also it can scrape through the dark web forums to understand what's going wrong, and then provide with the ways to proactively identify the threats. Like I was talking, anomaly detection is a powerful cybersecurity tool to identify the unusual patterns, wherein we already talked about the signature-based techniques, which usually identify the predefined set of signatures, but this is used to identify the unusual patterns. And for this, we have to use unsupervised learning, like clustering. Clustering is actually a computation method to identify to group the data points into clusters, and any deviation from this is actually flagged as anomaly. And to identify such anomalies, statistical methods like probability and variance are used. The key aspect on identifying these anomalies is a behavioral analysis of the user. Basically, like I was saying, the user is analyzed with respect to the user logins, with respect to the time at which they are logging, the location at which they are logging in. Those aspects will help us determine the anomalies. And one of the key aspects is zero-day threat detection. Like I was saying, any novel threat that is not undiscovered so far will also be discovered by this anomaly detection. And the key aspect about ML models used is adaptive thresholds. Let's say that we have Thanksgiving coming up, and then we expect a lot of logins to happen, a lot of odd hours of shopping to happen. So these should not be treated as like anomalies. So we should be able to adopt the thresholds by just decreasing the baselines, so that your model is not flagging them unnecessarily and lead to the fatigue of alert fatigue, right? Unnecessary false positive alerts will lead to alert fatigues. So with this anomaly detection also reduces the dependency on signatures. So we'll talk about the automated response systems. So AI can actually real-time respond to the threats. For example, the model can actually identify that a threat is coming up, and then it can also actually take an action on behalf of the security system as well. So some of the examples can isolate a system that it feels that it has been hacked. It can also block a user login. These are very prompt and should be done in a matter of seconds, and AI can help here. And it also helps in security teams incident prioritization. Basically, automating the priorities. Basically, there are a lot of threads that come in, but the top thread has to be taken care at first. So incident prioritization is key, and then automated response systems help in this. It also reduces the manual workload. Basically, these ML models, if cannot do everything, can also help in reducing the manual workload by taking care of trivial tasks that are usually happen, and then it's very well known. And then also there's some like AI is also treated and well integrated into systems, the software security systems. They will be able to identify and then and flag the high risk threats to the human. Like they are posed with this AI-based security, there are also cons. So what is the biases in training? Like we were talking about the AML lifecycle. Bias in training is one of the biggest problem to solve. There are hallucinations when we train the data. So some of the various ways of solving this. It could be by using some kind of grounding mechanisms that we can use. And then that's why the cleaning of the pre-processing of data is very much important before we train the ML models. And privacy concerns with data intensive models, basically when we train the models, basically it's around the user data, user logins, network logs, and this data we will have to follow the GDPR and California Consumer Data Protection rules. So such kind of protection rules have to be honored by the AI-driven, and this poses a challenge. And difficulty in explaining the AI-driven actions that were taken. Like today, AI models take an action, but it's very difficult to understand why it took an action. And we need to further work on developing these models where it's an accountability in the AI as well. Let's get into the evaluation metrics for success. While these models, like I was saying, one of the key aspect about AML models, and then also about evaluation of the metrics, basically continuously looking at the performance of the model. You know, these are the general metrics for many model. Let me just talk about them. True positive rates measures the accuracy of identified actual threat. If a threat is, if a model identifies this as a threat, is it actually a threat, right? And false positive threat, tracking the false alarms to avoid alert fatigue. Like I was speaking, alert fatigue is a bigger problem to solve in ML models. Basically, it can identify anything as a threat, but that will actually lead the security teams to be relaxed. They feel, okay, this is a false positive, and then that's relaxed, and then it is possible that we miss out on the actual threat as well. So we have to reduce the false positive rate of the model, and the precision is how often a model predicts positive instances. Basically, we can talk about it as like true positives by total number of positives plus the false positives. And the recall is like the system ability to detect all the relevant threats. So like we need to balance between the precision and recall. And so that's when we have this F1 score, which balances the precision and recall. One key aspect about the ML models is the response time, in which, like, how fast is the model able to respond. Now, let's enter the next slide. We are almost like 5 minutes away from completion. So, future of AI-driven threat detection. Like I was saying, explainable AI is the key in enhancing the transparency of which the AI took decisions. Basically, the enterprises and also the customers would expect why a decision was taken and the reasoning for which it was taken, right? That is actually missing. And humans are irreplaceable in this ecosystem. While AI can actually, while ML models can take the decisions and all, human and AI should work in conjunction to and then collaborate well in order to drive the future better with respect to AI-driven threat detection. And adaptive learning models, as we continue to see the new threats, we need to keep the model updated. And like I was saying, we'll just touch base about what do we mean by at what frequency do we need to keep updating. And this is always a challenge. Like basically, do we do it real time? Like data loses its value over a period of time. And at what point do you want to do? Do you want to do it in seconds, milliseconds? Do you want to do it in hours, or do you want to do it in days? That's the key aspect. And if you're doing it in seconds, how about testing it? How about testing it and ensuring the accuracy of the model that is built? And like I was talking with privacy preserving AIs, basically when you turn on the data from the users, how would you ensure that the data is not on a single system? How would decentralized federated data training, wherein the model base of model are trained separately and then bundled together? And securing the connected devices is also one. And then proactive threat hunting. Like today, if you look at most of these are like reactive, where the threat happens and then we apply the solution. How about like proactive mechanisms by using mechanisms like NLP, which escapes the forums like the dark web forums and messagings that happens, and then proactively view a possible threat that could happen. That's all from the talk. Thanks, everyone.
Do you guys have any questions for us?
Yeah, I guess like you were mentioning like one of the toughest things with compliance and like using some of the user data in California is like you have to follow that. And I guess like what is the greatest challenge that you face in regards to compliance with the government and training AI models?
Yeah. So basically, in general, right? Like we know day-to-day days, we actually show even the logs. Like basically, your user, the data is trained, the models are trained based on the logs, network logs. Even network logs, we actually anonymize most of the user information. Like even though we do that, there are certain scenarios where a username is entered by the user, though it's not intended, and that gets into the network logs. And network logs are used by the models to be trained, right? So that's a challenge. And dynamically identifying these fields do not accept the user values. For example, you're expecting, let's say, an organization you're working for, but you enter a personal information to them. That's something that's not avoidable, and then we have to inbuild. We have to come up with inbuilt mechanisms to or not allow something like a PID, personal identifiable information, to these fields.